Okay, today we're going to do some vocabulary basically to start our Unit 2. These are parts of an algebraic expression. The first thing we need to know is a variable. These are the letters that represent a numerical value in an expression or an equation. For example, you might have x, or you might have y, or you might have a, anything else like that. A lot of times they are written with a cursive type of writing as opposed to just a plain letter X, because otherwise that would look like a multiplication sign. Also, the Y might look like a 4, things like that. So it is kind of important to use the italic kind of version of this. The next thing we have is a constant. These are values that do not change in an expression or an equation. Mainly, these are the numbers that you see in the expression or equation that stand alone. They do not have a variable with them. For example, if I had 2x plus 16, the 2 is not a constant, although it is a constant in the sense that it's not going to change. It's always going to be 2. But we actually have a different term for this. The 16 that we're looking at right here, this would be the constant. And this is obviously a value that isn't going to change at all. It's just a number. There's no variable with it. So there's our constant. Next, we have a coefficient, a constant that multiplies a variable. When you see a number and a letter smack dab next to each other, that's when you know that you have a coefficient. Again, if we use the same example, 2x plus 16, as we're looking at this, the 2 here, this is my coefficient. The 16 is not a coefficient because there is no variable with it. The 16 still remains my constant. Terms are the parts of an expression or series separated by plus or minus signs. The parts of a sequence separated by commas is another way to say it. If I just had a set of values, for example, I might have something like this. I'm kind of starting with the second one first. I might have 2x, excuse me. I might have 2x, y, 3 to the third, and 2x squared y. These would all be different terms right there. So 2x would be a term, y would be a term, 3 to the third would be a term, and all this would be a term, 2x squared y. So again, if it's separated by a comma, sometimes you might see a semicolon as well to separate those. Now for the second part of this, or the other part, it says parts of an expression or series separated by plus or minus signs. Let's go ahead and just add this all up. Let's say that we have 2x plus y minus 3 to the third plus 2x squared y. When we look at it like this, again, if it's separated by the plus or minus sign, that makes it a term. So 2x is a term still. Y is a term. 3 to the third is a term. And then 2x squared y is a term right there. So that's just putting the plus or minus signs in between it. But that's what you're looking for. Again, make sure that you're noticing that the plus or minus signs is what separates the terms. For example, like this one here, this was the 2x squared y. All of that together is one term. So altogether we have 4 terms in that expression that I just did. Okay, like terms. These are terms which have the same variables and corresponding powers and or roots. Like terms can be combined using addition or subtraction. Terms that are not alike cannot be combined using addition or subtraction. So let's give an example here. Okay, first of all, let's talk a minute about the terms, because this is going to help us to combine it, because it says that we are looking again at terms which have the same variables or corresponding powers and or roots. So the first thing is, let me circle all of my terms. I have a 6x, there's a term. I have a 4y. I have a 2. I have a 3y. And I have a 2x. All right, from here, what I'm going to do now is I'm going to look at the ones that are the same. In other words, the ones that are alike. So right now, the ones that I can see, I'm going to start with my 6x. And I'm looking to see if I have any other x's here. I have 6x. And then if I go down here to the last term, I also have a 2x. And I'm adding that 2x. So 6x plus 2x gives me a total of 8 x's. All right, the next thing I'm going to look for is the y's, because that's the next thing in my expression here. So I have 4y, and I have 3y. And I'm subtracting that. There's a subtraction sign there for 4y minus 3y. And I'm going to combine those. So 4y minus 3y is just saying 4 minus 3. That's 1. That means I have 1y. So we're going to add just a y. And I don't need to put a 1 in front of it, but we do need to know that there is a 1 as a coefficient in front of it. And we'll talk about that in a moment. We also have, now all we have left is 2. So, and what we're doing there is we're subtracting 2. This is all we have left, so we're just going to continue this with minus 2. Now looking at this next line right here, there's nothing else that I can combine. There's nothing else that is the same. Because remember, looking at this, I have 3 terms now. This is 8x, so this is one term together. This is y, and this is a minus 2 or a negative 2. And that 2 here is all by itself. This 8 is with the x. That's that coefficient. So they're not really like terms, even though they both have numbers. I would have to have an x here next to this 2 if I was going to combine those, but I didn't have that. Okay, you've heard me saying already the word expression. This is a mathematical statement that has no equal sign. Again, if we just go back to this last one, if we had 8x plus y minus 2, there, this whole thing right here is an expression. There's no equal sign, or even the one we had before that where we were combining our like terms. An equation, obviously, does have an equal sign. So now we might say that 8x, so again we have 8x plus y minus 2 equals, and we can say something over here like maybe equals 20. And then we could solve for x and also for y at some point when we get to doing that. We're not going to be doing that here, though, now. We're just going to solve for single variables like x or y. Okay, combining like terms. Okay, I don't know what happened here, but this was supposed to say 8x plus 11 minus 3x was supposed to be here, so let's not look at that there. All right, so again, combining like terms means to combine the terms that have the same variable and the same exponent. In this case, I have an 8x minus a 3x. Those are my terms that are the same. So again, I just look at the coefficients. 8 minus 3 is 5. That means I have 5x, and I still have this plus 11. So there's plus 11. And this is all I can do. This is simplifying as well. When we combine like terms here, it also means that we're simplifying. So we simplified that expression to as like as simple as it can get. 5x plus 11 is as low as I can go, so to speak. Here's another example, a little bit more to do. Again, let's circle all of our terms. I have 6x, positive 4y. Sometimes it's good to put the sign with it because then you can see what you're doing. Minus 2, minus 3y, plus 2x. So there's all of my terms. They're all separated by those plus or minus signs. And now I'm going to combine the ones that are alike. So I'm going to start with the x's. So I have a 6x, and looking along here, I have another 2x over here that I'm adding. So 6 plus 2 is 8x. All right, now I have my y's. I have a plus 4y, and I have a minus 3y. That's the same thing we did before where it just became plus y. And then we have a minus 2. So basically, that's all there is to this, is just knowing what terms are. You have to, again, remember what your vocabulary is. I sure hope that you took notes on this. Make sure that you're now understanding variable, constant, coefficient, terms, like terms, expression, equation, and then also how you can combine your like terms. Make sure that you can also combine like terms, and you can tell how many terms are in an expression or an equation.